All right, good morning, everyone. This is going to be our next lesson for chapter 11. Actually, it's our last lesson, believe it or not. Um, we're probably going to have a test on this sometime soon. I'm trying to think if, yeah, I might have to assign that this week, unfortunately. But as you know, tests are going to be totally different since all the tests are going to be, well, at home. So we'll I can spend some time maybe going over that. But anyway, for right now, Metamorphic Rocks by Texture. Let's start. This picture in the front is actually really funny. If you look at what this is, it's obviously an egg. But it's an egg that was hard-boiled. Well, actually, it was 8 different eggs that were hard-boiled to different amounts of time. And the analogy here is that's kind of like a metamorphic rock. Depending on how much you cook a metamorphic, a rock, into a metamorphic rock, depending on how much time you cook it for, that will change what you see. So this hard-boiled egg was only cooked for a minute. Well, it actually looks a lot like a raw egg. So that's our analogy there. A rock that isn't cooked for a very long time will look a lot like the rock that it started out as. Whereas rocks that were cooked for a really long time, or an egg cooked for a long time, 15 minutes, will look very different than the original rock. So that's kind of our analogy here. All right. So metamorphic rocks are warped, so they change shape, and they're cooked, meaning we add heat, and that's how metamorphism happens. Okay, those are the two, I guess we could say, things we have to add to a rock to get it to metamorphose. So we have to add heat, and we got to add pressure. Now, some metamorphic rocks only require heat. So you take a magma, which is super hot liquid rock, you touch it to a cold rock, the rocks that are around it, and you burn it. You burn the rock. That's contact metamorphism. It's when magma touches touches cold rock. And yeah, like it says in the notes here, it's like a rock getting a bad burn. Here is a really good example of that. And actually I have a fun story behind this picture too. When I was in Arizona, I was driving through the plateaus that are there, all the mesas, and we're driving up to the Grand Canyon, and we're driving up this hill, and out of the corner of my eye, I've actually seen this exact thing here. This is, it was magma. It was a liquid. It injected itself into the earth, and you can see the brown discoloration right above that once magma. It's actually an igneous rock now. It's actually a mafic igneous rock. And you can see all the brown discoloration. That's actually the burning. That's the contact metamorphism. I was not able to stop, unfortunately. I wanted to stop, but I had driven too far, and we had to get to the Grand Canyon. There wasn't time, unfortunately. But I've actually seen this exact formation before. Really, really random. This is a place I've actually been. That's actually my finger. What you're looking at is this top rock here used to be lava, not magma. It actually used to be lava. And actually, I'm sorry. Is it lava or magma? No, it's definitely lava. It's lava because you can see all the vesicles here. And that once liquid rock touched the sandstone below it. So there's the contact. That's the place where it touched. And below it is a sedimentary rock, or at least it used to be a sedimentary rock. Now it's actually a metamorphic rock. And above it is the igneous rock. So that's the place where they contacted and the burning occurred. I am saying it's a sedimentary rock, but technically it's turned into a metamorphic rock. All right. So that was all contact metamorphism. Ooh, is it snowing outside? Oh, it's snowing outside. Anyway, that was really great. I'm sorry. Let's talk about pressure and heat. So when you add pressure to a rock, you can actually see it right here on the left. We're adding pressure to these crystals, and you can see how the pressure changes the minerals. They've actually become elongated. They've stretched out. And they're able to do that through a process that's called recrystallization. So you add a bunch of pressure to the rock is super, super hot, and the rock is basically freaking out. It's freaking out, and it does not want to be under all that pressure. So what the mineral does is, as a way to kind of alleviate some of that pressure, it recrystallizes itself and changes its shape. It deforms. It undergoes a deformation process, and it stretches and elongates. So that's how pressure. So we just talked about heat. Now we're talking about pressure and heat. And as you might expect too, pressure causes the rocks to become more dense. That makes sense. Because you're adding heat and pressure, you're crushing the rock, and you're actually making it more dense than the original igneous or sedimentary rock it came from. That's all part of something called regional metamorphism. And regional metamorphism is the most common type of metamorphism on Earth. It tends to occur where the Earth's plates smash together and collide. So if you remember from 7th grade, we'll go over that in the next chapter, plate tectonics. But places where plates come together, you can actually see it right here. We have this plate is sliding down, this plate is crashing in, and we have an entire zone here inside this mountain where metamorphic rocks are being formed. And you can see along the edge here, these are the original sedimentary rocks that are no longer. A lot of them have been changed into metamorphic rocks. So, okay. And as you might expect, the more heat and pressure you add, the higher what we're going to call it. It's called metamorphic grade is. So the more heat and pressure you add, the higher the metamorphic grade. And as metamorphic grade increases, the minerals in the rock change because of chemical reactions. There are actually chemical reactions going on inside the rock, believe it or not. And that's changing the composition. And also the size of the crystals change. The crystals generally get bigger over time. And we can actually see a progression here. I want to show off this progression because it's a really important one. Here we have shale. That's a sedimentary rock. And you can see where the shale is. It's very far away from where the collisions happen. I'm actually going to go back for a second. You can see the collisions happening over here. This is where the maximum force, the maximum temperatures and pressure are. But see, back here, it's so far away from the collision that back here we have all of the original, it's called parent rock. It's the rock that the metamorphic rocks come from. They're unaltered. But as we go closer and closer and closer and closer to the core of the mountain where all the pressure is and all the heat is, the rock changes. So what you have is the progression. A shale, if you add some heat and pressure, turns into a slate. More heat and pressure turns into a phyllite. Then it turns into a schist. And the last rock is a gneiss. If you were to add more heat and pressure from this point on, as you might expect, too much heat and pressure just causes the rock to melt. So metamorphism is limited. You eventually hit the melting point of the rock, it melts, and that's that. You actually have an igneous rock at that point. Okay, this is on page 7 of your reference table along the bottom. You can actually see it right here. Regional metamorphism, type of metamorphism. It says heat and pressure increases, and you can see all of the ways that the mineral changes. The rock changes. You can see how the composition changes of the rock over here. Okay. You can see how the grain size is changing, and the rock name will change. And again, this is regional metamorphism only. So a big recap here. Contact metamorphism involves heat only. So you can see over here, we have a bunch of magma, and it's touching the cold perimeter here of the country rock, of the rock surrounding it. And that's causing contact metamorphism. The heat can't transfer very far, so not a lot of the rock is burned. It's, for the most part, it stays the way it was. Regional metamorphism happens over gigantic areas, very, very big areas. Sometimes 100 miles, of a collisional zone can be altered. So we're talking about very, very, very big areas. All right, so, I did not edit this correctly. I should have edited this better. So along the top here, we have our regional metamorphic rocks. And you can see it says regional, and then we have regional over here. These rocks can be regional or contact, okay? All right, let's go over the textures. So there are basically two textures that a metamorphic rock can exhibit, upon being metamorphosed. The first texture is called foliated, and we've already seen foliated. It's when the mineral crystals align, they elongate, and, when we say foliated, that's actually what that pretty much means. It means there's some type of alignment in the minerals. Whereas, again, non-foliated, you can see this non-foliated, it's a marble, this pink marble. It's non-foliated. Now, it is metamorphosed from a limestone, so limestone turns into marble. You can see the minerals don't align, and it's just the way those minerals behave. They don't align. The last texture that we should talk about is banding. And banding is basically just foliation gone to the extreme. So here we have a schist. It is quite foliated, but if we were to add intense heat and pressure, very, very intense heat and pressure, we're talking about heat and pressure that is occurring near and around the core of a mountain that's being built when two plates collide. So intense heat and pressure. Those minerals will start to align into bands, discrete light and dark bands. Okay, that's going to be a gneiss. All right, and all that is occurring right here. You can see gneiss. Okay, banding, big minerals. You can see all the minerals that are in there: mica, quartz, feldspar, amphibole, garnet, pyroxene. You can see that it's the result of the most heat and pressure. It says high-grade metamorphism, mineral types segregated into bands. Okay. All right, that's metamorphism. That's metamorphic rocks. There'll be a test wizard on this. There'll be that assignment you'll have to do for today.